Chemical structures of organic compounds. Chemical structures of organic compounds are the key to understanding their properties and reactivity. Organic compounds contain carbon atoms bonded to hydrogen atoms, and often to other elements such as oxygen, nitrogen, sulfur, and halogens. In this article, we will explore the different types of chemical structures found in organic compounds, and how they affect the properties and reactivity of these compounds. Functional groups. Functional groups are specific groups of atoms that impart characteristic chemical properties and reactivity to organic compounds. They are responsible for the wide range of properties and functions displayed by organic compounds. Some common functional groups include alcohols, contain an O group, such as ethanol, CH3CH2O. Carboxylic acids, contain a CU group, such as acetic acid, CHICU. Amines, contain an NH2 group, such as ethylamine, CH3CH2. NH2 aldehydes, contain a CHO group, such as acetaldehyde, CHECHO. Ketones, contain a CO group, such as acetone, CH3 2-coesters, contain an CU group, such as ethyl acetate, CH3-COOH2 CH3 amides, contain an CON 2 group, such as acetamide, CH3 CON 2. The presence of a functional group can greatly affect the properties and reactivity of an organic compound. For example, alcohols and carboxylic acids are often polar and can form hydrogen bonds, making them more soluble in water than nonpolar compounds such as hydrocarbons. Isomerism. Isomerism is the phenomenon where two or more compounds have the same molecular formula, but different structures and properties. The different types of isomerism found in organic compounds include structural isomerism, where the compounds have different structural arrangements of their atoms, such as butane and isobutane. Stereoisomerism, where the compounds have the same structural arrangement of their atoms, but differ in the arrangement of their atoms in space. Stereoisomerism can be further divided into geometric isomerism, where the compounds have different arrangements of their substituents around a double bond or a ring, such as cis and trans-2-butene. Optical isomerism, where the compounds are mirror images of each other and cannot be superimposed, such as L and D-glucose. Isomerism is an important concept in organic chemistry, as it can greatly affect the properties and reactivity of organic compounds. For example, the two isomers of glucose have different biological activities, with L-glucose being essentially inactive and D-glucose being the primary source of energy for living organisms. Polymers. Polymers are large molecules composed of repeating units called monomers. They can be formed by a variety of reactions, such as condensation polymerization and addition polymerization. Some common polymers include polyethylene, a polymer of ethylene monomers, used in packaging and insulation. Polypropylene, a polymer of propylene monomers, used in packaging and textiles. Polystyrene, a polymer of styrene monomers, used in packaging and insulation. Polyvinyl chloride, PVC, a polymer of vinyl chloride monomers, used in pipes and flooring. The properties of polymers can be tailored by varying the monomers and the conditions of polymerization. For example, the addition of certain monomers can improve the strength or flexibility of a polymer. Organic reactions. Organic reactions involve the breaking and forming of chemical bonds in organic compounds. These reactions are critical to the synthesis of new organic compounds and the modification of existing ones. In this section, we will explore some common types of organic reactions. Addition reactions. Addition reactions involve the addition of one or more reactants to a multiple bond in an organic compound, such as a double or triple bond. The multiple bond is broken, and the reactants add across the newly formed single bonds. Some common